Hey guys, we're gonna start looking at exponential functions in this unit, which will lead us into logarithms. So this first question is just having you pick a graph, and it's okay if you use Desmos. So y equals 3 to the x minus 3. And what this minus 3 does is it takes the graph 3 to the x and it shifts it to the right 3 units. So 3 to the x goes through 0, 1, and then this goes through 3, 1. So I just want to find that graph that goes through 3, 1 right here. So it's graph F. Right. So you should have just one of those, and then the rest of them are solving. So I'm going to start with this one, where our base values are the same. So see how we have 6 to the power of something and 6 to the power of something? Once the bases are the same, then we just solve the exponents. So I have negative 4x equals negative 9x minus 3. And I can drop the parentheses because it's no longer an exponent. So for here, I'm just going to solve plus 9x on both sides. So I have 5x equals negative 3. Divide both sides by 5. So x equals negative 3/5. Right here. So that's when they're the same. You're going to come across problems where the base is not the same. So we want to rewrite the larger base, so 8, using 2 to the power of something. So I want you to think 2, and I'm using 2 because that's the base that I have right here. 2 to the power of something is 8. And you might have to do some calculations, but I know that 2 to the third is 8. So I'm going to replace this 8 as 2 to the third, and then there's still an x plus 8 right here that I'm using. Alright, and then I'm going to bring down this 2 to the x. So now that my bases are the same, I can solve. So I have x equals 3 times x plus 8. And I'm keeping the parentheses this time because I need to make sure that 3 is distributed. So I have x equals 3x plus 24. And from here I'm just going to solve. Minus 3x on both sides. So I have 1 minus 3, which is negative 2. Divide both sides by negative 2 to get x by itself. X equals negative 12. So none of these are correct because it's negative 12. Okay, so let's do some more. I tried to pick the ones where the bases were not the same. So I'm gonna take this, and negative 10 over negative 50 reduces, these both divide by negative 10. So this reduces to 1 over 5. So now I have 5 to the 7x plus 2 equals 1/5 negative 5x. So we're super close to having these the same. So what we do is when we want to change the sign of this, maybe you remember, cross the line, change the sign. if I make this over 1, then I can bring this whole thing, I can switch the exponent and make it 5 to the negative 7x plus 2 equals, and then this isn't the same yet, this isn't 1/5 because this goes to both the 1 and the 5. So this is 1 to the negative 5x, and then this is 5 to the negative 5x. So we're close, but now I'm going to solve this part. Now these bases are the same. So I have negative 7x plus 2 equals negative 5x. And this negative has to be distributed to both. So negative 7x minus 2 equals negative 5x plus 7x plus 7x. So negative 2 equals 2x. Divide both sides by 2. X equals negative 1. So I'm going to put negative 1 in right here for x. Alright, so one more. Again, our bases aren't the same here, so I want to rewrite 64 using base 4 because that's what's right here. So 4 to what is this equal 64? If you don't know, just start typing in values. 4 to the third. So this will be 3. I'm going to rewrite this whole thing, 4x minus 5, but instead of 64, I'm going to write 4 to the third. Once my bases are the same, I have x minus 5 equals 3, plus 5, x equals 8. So I'm going to put 8 right there. Okay, if you have more questions on this, you can ask. Good luck, guys.